Hello everyone, in this ocean simulation tutorial we will continue our tutorial part 3. The next stage we will use inverse Fourier transform to transform this spectrum from the frequency domain to the spatial domain, and we will set it to the displacement grid. Sorry that I create some mistake here. Because this displacement grid, I use the emitter parameter, so remove this pin. Module input, I don't have this displacement grid, so add this grid 2D collection. Name is displacement grid, and add displacement grid input and connect it to this grid, and also the set displacement grid emitter, and apply and compile. Now you can see this displacement grid, and we set this to float. Let's save and add new script, diagram module script. The name is FX Ocean Water Roughness. And you can add another one, is FX Ocean Water Column Pass, Whole Pass. Now open this row pass first, script detail, use it in particle simulation stage, and expose keyword ocean water. Then we add the parameter module, local is integer, ignore, and module input grid 2D, name is FFT grid, integer, grid size, and integer, name cascade. The map get, we add FFT grid input, grid size, input, name cascade input, and we add ignore map set. Create a custom HLSL, and we go to this project and we copy this snippet, pass it here, and set this absolute include file path, add new, and set it to the ocean water FFT US8 file. Connect FFT grid size and this new cascade, and connect this ignore, and let's compile. We have some error. Sorry, we copy the wrong code here. Let's delete. We need to copy this HLSL expression code, pass it here, and this CPU simulation. Let's compile, and now we have some error, but it's okay with this error. Apply and go to FH Ocean Water at stage, generic simulation stage. The name is iFFT Roughness. And set this to direct set and 2D. Use grid size and this grid size, and we override GPU dispatch 256, and this one is 1, and add the row pass, then select FFT grid emitter, grid size, and num cascade, and let's compile and open another column pass, and we go to script detail, disable all of this, set to particle simulation state script, and expose to library, and the keyword is ocean water. Go to parameter, compile and apply this, add module local integer, ignore module input is grid 2D, the name is FFT grid, add integer, grid size, integer, num cascades, and add grid 2D is displacement grid, and we want to inverse, and we want to transform the frequency domain to the spatial domain to save in this displacement grid, and add FFT grid inside this map get, grid size, num cascade, and this displacement grid, and create add ignore, and call custom HLSL. Next this to this ignore, and you can add this, include file path like ocean water FFT, and we copy the last HLSL expression code, copy it and paste it here, and we comment this out is whole path, and comment this row path, and connect this to the custom HLSL, and let's compile and apply. We get some error here, but it is not any problem. Go to FH Ocean Water and add state to simulate generic simulation stage. Rename it to iFFT whole pass and direct set is 2D and this grid size and grid size. Override GPU dispatch 256. And then we add the whole pass and set this displacement grid, FFT grid, size, and cascade. And this, if you don't have this displacement grid, you need to go to this. Make sure it is input displacement grid in this module inputs, and then connect it to this displacement grid emitter. And let's check if this simulation is correct. We save all first and go to ocean water set grid and preview this displacement grid. If you see this same result, it means that your inverse Fourier transform is correct. Now we export the foam data to render target. We need to create module script. Niagara module script. The name is FX ocean water and export data. Open this. Script detail. Disable this and expose. Keyword is ocean water. Apply and go to parameter. Module local is integer. The name is ignore. And module input is grid 2D collection, displacement grid. Vector 4, foam blur. Vector 4, foam fade. Grid 2D collection, foam grid. Vector 4, foam multiplier. Vector 4, foam threshold. Integer, grid size. Vector 4, hash length. Render target 2D array. RT vertex attribute. Render target 2D array. RT vertex attributes B. And then we add to the map get grid size, displacement grid, RT vertex attribute, foam multiplier, foam threshold, foam blur, foam fade, foam grid, data time, patch length, RT vertex attribute B. And this map set is ignore. And then we create 8 LSL custom, and we go to this foam simulation attribute export stage and copy this custom expression code and paste it here. And select add absolute file path and select the file location is Ocean Export. Then connect to this add. And this result connect to this ignore. Now let's compile. Go to ocean water. We add the state to generic simulation state. And this state name is foam and export. Direct set. And set it to 3D. This grid size, name cascades. And then we add the export data. FH ocean water export data. And select the displacement grid emitter, foam grid emitter, foam blur, foam fade, foam multiplier is foam injection, foam threshold, grid size, patch length, vertex attribute, vertex attribute B, and we compile and save all of this and open this set grid, and you can preview this foam grid. And if you get this result, it means it is correct. And then we export all the cascade value data. Need to FX diagram module script. The name is FX ocean water export pixel data. And open this. Go to script detail, the same as before. This one expose. Keywords is ocean water. And parameters, module local, integer, ignore. Module input, integer is cascade selector. Grid 2D collection is form grid. Grid 2D collection RT pixel attributes A. Grid 2D collection RT pixel attribute B. Then we add it to the map get. Cascade selector, form grid, pixel attributes A, pixel attributes B. That is ignore. And then we create a HLSL and copy this code snippet as it, and this cascade selector, form grid, pixel attributes A, pixel attribute B, and this ignore. Let's apply. We have some error. The error caused by this RT pixel attributes A because we set the wrong type. So remove pin and remove this pin, and we delete this. Compile and we add again is render target 2D RT pixel attributes A, render target 2D RT pixel attributes B, and we add RT pixel attributes A, pixel attributes B, add it to this custom HLSL. Compile, and now we don't have any error. Apply and go to FH Ocean Water, add a new generic simulation state. The name of this stage is Export Pixel Cascade 0, and direct set 3D grid size, name cascades, and we add ocean water export data, export pixel data, and set this Name cascade is 0 because we export the cascade 0. Foam grid. Pixel attributes. We chose this pixel attributes has 0. Pixel attributes B has 0. And save. And we can check it by go to this ocean water, set render target, and preview this pixel attributes as 0. Preview. Here is the render target. You can add this Niagara system inside the project and save. And you can go to this render target and open this as 0. And this one as B. It is the correct render target texture. And this vertex attributes is working correctly, both of it from A to B. We need to export the pixel from cascade 0 to cascade 3. And we add a new state, generic simulation state. The name is export pixel cascade 1. The same as before, direct set, 3D, grid size, name cascades. And this one is export pixel data. Cascade selector is 1. And we search for foam grid. Pixel attributes as 1. Pixel attribute B has 1. Compile. Add the next state. Export pixel cascade 2. And direct set. Grid size. 3D. Grid size. Name cascade. Export pixel data. And 2. Foam grid. Pixel attribute has 2. Pixel attribute B has 2. And the next state is export pixel cascade 3. Direct set and select 3D, grid size, name cascade, then add export pixel data. Cascade selector is 3. Foam grid. Pixel attributes has 3. Pixel attribute B has 3. And compile. We save all. And we go to render target and pixel and open it one by one. See if it is working. So all these pixels are working correctly with this vertex attribute. Next, we will export the roughness. So we need to go to Effect module and add another script. FX ocean water roughness integrator. Go to script detail, disable this, expose ocean water. Go to parameters, and we add the parameters module local integer ignore, and module input integer integration sample. Vector for page length. Add grid 2D collection. Roughness grid. Float. Roughness power. Texture sample. RT pixel attributes a casserole. Can copy this name and add texture sample as 1. Texture sample as 2. And texture sample as 3. And then render target 2D RT roughness. Next, we add it to map get page length roughness grid roughness power integration samples RT pixel attribute a casserole RT pixel attribute a cas1 RT pixel attribute a cas2 and cas3. And RT roughness. Then add this ignore set map set. ALSL custom. And we need to go to this roughness integrator stage. Copy this code snippet and pass it here. Need to add. We use the same name as the module parameter and connect it to ignore. Let's apply this. it have some error, and we need to change this. We get the error from pixel attribute A as 0. It's not contain function sample and the target value because this type is texture sample. So we need to change this function. We change it to sample texture 2D, and this we add another row. The same with the above function is texture 2D and 0. This texture 2D and this 0. Texture 2D and this 0. And this attribute A is the same. You can copy all this row C and paste it here, row V. And apply. Now the script successfully compiled. Go to ocean water and add another state. Generic simulation state. The state name is Roughness Integration. And choose data interface. Like the data interface is roughness. Search for roughness grid and add the roughness integrator. This integration sample, choose roughness integration samples, choose roughness grid, roughness hour, and this pixel attribute A. Search for attributes casserole. Attributes has 1. Attributes has 2. And attributes has 3. This roughness, search for OT roughness. And we compile. Can view it here, the render target pixel in this. Our roughness should have the red color, so it is not correct. We check it again. Roughness integration, and because I forget to set this page length, so set this page length and compile. Let's see our roughness, and now it is red. When we zoom in, you can see this red line. We already finished the Niagara simulation of our water. Next, we will create the material for this ocean. For our material, we will download the project file so we can migrate that material. It is faster to get the result. Click on this project file and download this sample project. Download zip. After you download, create a new folder, name Niagara, and move it here. Then extract here. Open this project with Unreal Engine 5.3. And open this material. And you can see this all the material function. You can create it from scratch, but we will migrate this. Like this material and migrate. And we don't migrate this render target and this texture. Only this material. Click OK. Choose your file location, your project location, Ocean Tutorial, and content, select folder. And after you migrate it, you can see this is the material function. Some material is not working because we have to set the correct texture for this. So open this, adjust color. We don't have any error. MF foam. We get one error from the require valid texture. This one, we need the normal texture of the water N. And this one, water D. And apply. Next is grab cascade. This grab cascade attack, we get the error because this one we can preview the material. So stop previewing node and save it. And next is grab cascade attack vertex and choose the vertex. Search for vertex. This RT ocean water vert attributes. And this one, RT ocean water vert attributes B. Apply. Next is MF grab pixel attributes. Choose RT pixel attribute as 0. And next is attribute B cast 0. And attribute cast 1. Attribute B cast 1. Attribute cast 2. And attribute B cast 2. This one cast 3. Attribute B cast 3. And we get this. material, apply, and grab roughness. We have the correct material, just stop reviewing node. Then grab vertex attributes. It is correct. MF scatter. We don't have any error. So go to the material. We can save all. This ocean. Select the foam texture. Water D. And this one is water N for the foam normal. And this is roughness or T roughness. And this material is working. Apply. We can save. And we drag it onto this plane. And this plane have the motion of the wave. And we can scale this to 20 X, Y, and Z. And move it up a little bit to 4000. And change the camera speed. Now we already get this ocean wave. And you can see this foam. It have on the wave. We cannot use this as the finished project yet because this is just a plane and we need to optimize it and spawn it in the big area. But this is the end of our tutorial. If you would like me to continue this project, please let me know in the comment section below. Thank you very much for my patrons member who are supporting me. If you like this tutorial, please hit like and please subscribe to my YouTube channel. Thank you very much for watching. See you in the next tutorial.